Welcome to the session on domain-specific language. So DSL stands for domain-specific language, not this internet connection thingy. With Xtext. My name is Sven, and I've been the project lead for the Xtext project, which I'm talking about since its inception. And I come from Kiel, Germany. And I work for a company called Efftinge, and we are basically doing this open source project and making money with doing consultancy around it, so helping people using this framework in products they sell and so on. So actually this is Kiel, and this is our office here, and I should have come with a ferry because there is directly ferries going from Kiel to Oslo, but I chose to fly, and I was lucky there was no strike for me. So I'm glad I can be here. Before we talk about how to build a DSL, let's briefly capture what a DSL is. It basically is a programming language, right? And the specialty about it is that it is not a generic one that can be used to solve all problems in the world, but it's one that is tailored for a particular problem. Regular expressions, for instance, is a domain-specific language, or all kinds of query languages are domain-specific languages. And if you look into specific domains, then you see a lot of very kind of strange languages for us that we are not experts in this domain, but that are like very helpful tools for the domain expert in that domain. So, what's the benefit? Why would we use a domain-specific language? When it comes to software development, then I think software development is all about abstractions. So we are layering abstractions. We build kind of from small pieces, we build bigger pieces. So when you define a method, for instance, then you give it a name, and that's an abstraction, and then you can call it multiple times, and you have bigger methods that call many other methods and so on. Then we have classes. And so these are the kind of the building blocks for software systems. And if you think of it like with the analogy like Lego building blocks, then you know that in Lego there is certain kind of Lego themes like Lego City and so on, and also advanced stuff like Lego Techniques, which have a lot of specific building blocks. And a domain-specific language lets you come up with any kind of building block, and that must not necessarily be built off the smaller bricks, right? It's very suited to a particular thing, and it's only useful in that domain mostly. So that's why I put in the 3D printer in the first slide. To me, this is kind of like if you can print your own 3D Lego bricks, that would be fun, right? With Xtext, you can build your own kind of Lego bricks for software development. And then the next thing is that, like, if you consider that software is going everywhere in every industry, software becomes the most important asset, even so stuff like automotive and so on, then it's clear that there's many people who want to write the software or need to participate at least in the writing of software. So what we do when we do business software is that we talk to people who know the requirements very well, and then we get this requirement and we translate them to software, right? And then we show the software, and the business people say, well, yeah, that's what I meant, or no, that's not what I meant, and what about this and that? And we all know business people don't really think formally often and don't know what to do. But there is this gap in this requirements engineering problem. And you can use kind of formal formats to improve the communication between these people and the software development stuff. So you can even have kind of very important parts of your system written in a DSL that is readable to these business people. Think of a product for insurance, like insurance product configuration. It's a very complex problem that software developers often can't understand because you really have to be an expert in that domain. And then you have the domain experts, And so what if you could kind of have a formalized way of writing these insurance contract thingies and let them kind of, like, the business people read it, and so you work on the same thing. You do pair programming with business people, so to say. And then another property is that you can just simply have late binding, which means instead of writing code and compile it and then deploy it, you can also have code, which means behavior, that is configured at runtime and changed later. So you can do this kind of things with JavaScript and so on as well. But think of, for instance, this insurance contract thing where you have a special administration mode in your application where people can configure certain behaviors of your software system. So in some constraints, of course. And yeah, so these things can be done with domain-specific languages. So who of you has been doing a programming language before, or a domain-specific language or something like that? Anyone? Okay, a couple of you. So the first thing, I guess that you all know that, at least from university, if you do a textual language, the obvious thing you need is a parser, right? So people think, okay, I'll use a parser generator. You should use a parser generator at least. Don't write it by hand. It's a solved problem. For parser generators also, you have domain-specific language, which is a grammar. And from that, you generate a parser. So, but then, what a parser does is it reads in text and it recognizes it somehow, and then at some point you need to do something. So you want to do side effects during the parsing, or even better, you create an in-memory model, a so-called abstract syntax tree. That would be your domain model of the parsed text. And then you can use that domain model in order to do something. So far, such a DSL would be useless. You need to do something. And there's basically two things you could do. One is you write a code generator. So you pass in this AST into some code that generates some other code for a language that exists. For instance, Java. You generate Java code or C code or whatever. By that, you give your language meaning, semantics, so to say. You translate it to another language that has already a formal definition. The other way is interpretation. So you read in the model at runtime, and then you inspect it and do side effects based on what the structure looks like. Then also you want to do validation of the model, because the users of a language, they want to have fast turnarounds. I think there is little worse than bad turnarounds in software development. We all know that. And so the same applies for when you use a domain-specific language. It should give you instant feedback. So you need validation. You don't want to wait until the compiled Java code breaks, or even at runtime problems occur. All right, so then the next thing you need is you parse the text. You have an AST, so a tree. But then, if you really think about these structures, they are graphs. A method call, for instance, in Java is really pointing to a declaration of a method, right? So you need to establish these links. And that's done by scoping rules, name scopes, and so on. And then you have types, and you want to do type checking. And then you want to improve on the status quo. So if you provide a statically typed domain-specific language, then you cannot explain business people or anyone that he has to over and over type and write down some types and so on. So you want to use type inference, for instance, also for that, if you have these kind of things in your domain-specific language. All right, so there's a lot of things you need to implement in order to have a DSL. And there's still something missing, and that is the tool support, right? I mean, no one wants to write in a text editor, especially not for a language that is kind of special and has a lot of keywords and so on. It's maybe tailored for readability. So you also want to have a rich editor that helps your clients editing the files, give fast feedback, and so on. And there's many properties you need to think about and implement that. And then you have this DSL, and you've maybe implemented an Eclipse plugin, and then what about the other guys in your team that use IntelliJ? Well, you need to support them as well. And then you want to talk to the business people, and they won't ever open an IDE, of course. So think about having like a browser thing there, like show the editor in the browser. These are all things you need to care about if you want to build a modern textual programming language. And so that it seems like there's a lot of effort involved in that. So better, let's try to use some existing language and shoehorn like syntax into it as much as possible. That's called internal DSL. And that's really a reasonable approach unless there is some other technology that would help you with all these tasks. And that is what Xtext does. So Xtext is an open source project. It's based at Eclipse.org. That doesn't mean it is Eclipse only. It supports also IntelliJ and web editors since October. That is next month. It is based on that there is a grammar language, obviously, where you describe the language, the syntax, but it's a bit richer than typical grammar languages. So in this grammar language, it's actually a bidirectional mapping between text and an AST. So it's also an unparser that is derived from that. Something you have an in-memory model and you can write it back to text. That's also possible. So it's a bidirectional parser. And we can derive a lot of other interesting things from this grammar. And then it's a bit Spring-like from the architecture. So you write the grammar, you run a code generator that generates some bits, and then there's a lot of generic implementation for linking and validation and stuff that is wired together via dependency injection for you. Xtext uses Juice. And if you ever need to change something from these defaults, which are proven and really used in many applications, then you can change the bindings in the dependency injection. And you can literally override every method in the system and change how this or that works. So you get all the things for free just by writing the grammar, and then you can go and change stuff as it seems fit. Yeah, it supports multiple platforms. Right. And it also supports continuous integration in the sense that there is Maven plugin and Gradle plugin to run like your compilers in without IDEs and so on. The compilers are also integrated into the different IDEs, but you can also just have them in the Gradle build and so on. And also the Xtext project itself can be integrated in a build, of course. All right, so that's the introduction. Let's go to a demo. For that, I choose the domain of home automation. So anyone knows OpenHAB? Okay, some. That's a project, an open source project for home automation. And home automation, I think most of you know what that is. It's just like you have your house and you have a lot of sensors there and motors and stuff, and then you connect the things together and put some great logic into it such that, for instance, you can save some energy or so and you can observe what happens. So let's switch to the IDE. What I want to do is I want to implement rules for my home. Right? And I want to have these as an example. I have a window and I have a heating, and I want to close the window when someone turns on the heating, and vice versa. I want to turn off the heating when someone opens the window. So I have these kind of if then else dependencies between the states of my house. Okay, and I just choose some syntax which I found was readable. I want to implement this language. I will do this in Eclipse for now. So what you can do is in Eclipse, if you have the latest Xtext plugins installed, is you create a new Xtext project. Actually, it's a set of projects. And therein, I've some preparation here, so you don't need to watch me typing. In this wizard, there you provide the project name, and then you provide the language name, and I call it rules. And the file extension for the text file, I also call rules. And then you just click finish, and you get this 3 projects here. So that's the currently released version of Xtext. As I said in the beginning, there will be a new version coming out very soon, where in the wizard there's an extra page where you select what kind of target IDEs you want to have, and also what build system you want to use. So Gradle and Maven will be supported there. All right. So then the first file that is opened is the Xtext grammar file, and it comes up with a Hello World example, of course. And I'll just put the example text on the right-hand side and paste in the grammar for our language here. And then I explain what it does. Okay. So there's the first 2 lines are kind of preludes. So you declare what the language is, what the name is of the grammar. Then you can inherit from a super grammar, so you inherit rules from there. The next one is there we declare that we want to generate an AST abstract syntax tree, and so Xtext will really generate our Java Bean classes. They are actually EMF classes, Eclipse Modeling Framework, but that doesn't really matter. What matters is that you get a statically typed API to work with your ASTs, just from this grammar. And then there is the rules, and that's the interesting thing. So it starts with the first rule, right? And we want to recognize this text here. And we say, well, such a file is made up of declarations. And a declaration really is just an abstraction over device or rule. That's how you read this bar here. It's an alternative. So first we have 2 devices, the window and the heating. In order to parse this, we write this rule. We say there's a keyword device, and then comes an identifier, that is ID. We have imported this rule from the supergrammar. ID is just some name, some Java identifier basically. And we assign it to a property called name. So when this rule gets executed, the parser will create an instance of the type device and assign the name that is in this ID here. So it will be window. And then we have the 2 keywords can be, and then we have a comma-separated list of more identifiers, and we say, well, each identifier is a state. So we get a real object there. We could also have a list of names, but we want to have a state as an object. And this is done like this. Actually, the question mark here is not necessary. So, but I can explain what that is. So the question mark means this is optional. So actually, this would be valid given the grammar, but it doesn't make so much sense. So I remove the question mark. And I also don't need the parentheses then. And but then we have a mandatory state, and after that we have any number, so the asterisk means any number, of comma-separated additional states. And they will add it to the feature state here. Okay? Of course, this language is built with Xtext. I think that's obvious. The other rule here is called rule. The problem with this kind of thing is that you often get confused with these meta terms. The home automation rule will be passed by, like, there's a keyword rule, and then some description, which in this case is a string, So we have a string literal here, switch off heating when Windows gets opened. Actually, I don't think that's needed. Maybe we should remove it because the DSL itself is so readable that it like repeats it somehow. You know how it is with documentation. It tends to get out of sync. Then we have the when keyword, and then this is a very interesting concept that you won't find in any other parser generator. The square bracket denotes a cross-reference. So what this means is you will see a qualified name, so parse a qualified name, and then look up in the scope a state with that name. Okay, so we reference states here by qualified name. And the qualified name is just identifier dot identifier dot identifier, like in Java. Questions so far about the grammar? You all had this Bacchus-Nauer form stuff at university, I hope. And that is really, like, if you have that, then that's most of the things you need to know. So I save it, and now I can just click right into the editor and call generate Xtext artifacts. So this is an IDE action, but again, this is also available through a Maven plugin or so. And it will generate some code here, some default implementations, create some default juice module to bind the default implementations, and then it will also generate some classes which are initially empty, where you can put your customized stuff. So if the defaults are not good enough, then you can go and implement the scoping differently and the validation, add some validation rules and so on. But before we go further, we want to write a unit test because we want to see how it feels. So I'm going to create a unit test, JUnit4. I could use Java, of course. Everything's implemented in Java here. I'll use Extend instead because it's better suited, as I, for instance, need multi-line strings and Java doesn't have them. Just Extend is a programming language that just translates to Java source code directly. And it doesn't have its own super crazy type system or something, but it has a lot of very cool productivity enhancers, reduces the noise, has rich type inference, stuff like extension methods, and very important also for this kind of topic, a template expression that lets you do code generation in a very maintainable way. We will see that in a minute. But it should be very readable for you. It's basically Java without clutter. So it's JUnit4. We want to have our own runner. And also we will use dependency injection, and therefore we configure this with an injection provider. That class is generated. It's generated for a unit test. We'll make sure that dependency injection happens around the unit test transparently. Any side effects will be taken care of between tests and so on. Now we can inject anything from the language infrastructure, for instance, a parse helper. And we parameterize it with the root node of our grammar. So the first rule, you remember, it was called model. Xtext generated a type model from that, and that's the root node of our AST. And now I can write a test. And use a parser and use a multi-string literal here and paste in my domain model. What is that? So what you see here with this gray space stuff, a typical problem in code generation is, or with templates, is that in templates you have white space all over the place in order to format the template, right? But then there's also white space you want to have in order to format the output. And so usually, or not usually, every template language in the world cannot distinguish between white space that needs to be layout information for the template and white space that should go to the output. And that's one property that Xtend can do, and it will tell you by using this special highlighting. So we have white space and gray space. So it means that this indentation stuff here, you won't see it in the output. It's not there. Okay, and now we have a model here that is, and we can just print it. We use a special toString implementation. And now I run this test. And so we see that is the toString implementation for the AST we just created through parsing this text. So we see we have a model as a root, and then we have declarations here in it. And number one, we have a device, which is a name window, and that has two states, open and closed, and so on. So it's really like the AST is created. It's not really a test. It's more like I want to show you something. Of course, if you want, and you should write test, then you do kind of like assert model.get declaration size is 4, something like that, right? So you do kind of checking stuff in the model. What you shouldn't do is compare the toString implementation, because that's fragile, obviously. And you can do that, but it's fragile. So. All right. Questions so far? Okay. So then I have a more advanced unit test. Prepared here. I have to organize imports. So it does the same. It parses this model. Okay. This time I've imported the parse helper as an extension, which means that the parse method is now projected on char sequences in the scope. So that's a feature of Xtend. So you can write a string literal and dot parse. It's just sugar. Then we have validation, because when you write tests, you of course want to make sure that you don't check for wrong models. I mean, it's a good idea to have tests for wrong models as well, but sometimes you wonder about assertions and then you figure out you have done a syntax error in the first place. So we do a validation here. For that we have injected a validator, and then we want to generate some code, because that's the whole purpose of the code of this DSL. We want to produce some code, right? And for that we inject the generator, and here we call the generator. Generate do generate, we pass in the model, and then file systems access. That is just a thin facade over the actual file system that is in use. This code, the generator, needs to run in Eclipse, in IntelliJ, and on the file system, Java.io, and Eclipse and IntelliJ have their own file system abstractions, with a lot of kind of observable support and so on, so we need to use that. So that's a thin abstraction, and then we just check later whether the generated code contains this bit of Java. And if I run it now, then it fails because the code generator is empty. Okay? But I can fix that, because when I generated my grammar the first time, it proposed me a generator. That is the default. Typically, you want to write a generator. If you want to do it in an interpreter, you can configure it that you don't want to have a generator. And so you get this code here, which is just a callback, and you can implement whatever you want to do in code generation. And this hook will be automatically called from the different life cycles. So when you hit save in Eclipse or in IntelliJ, you just type and it will be executed on the fly. It should be fast, by the way. And in Maven plugin, it will also be executed and so on. So I could write stuff here, but I have prepared a real code generator. And so the main thing is that we generate from every model, we generate one Java file. And then you see this long template expression there. And you see the templates not only have this gray space, white space property, but also you can have for loops in it and if statements. So the if is not used here. But what we really do is we generate some Java code, right, with methods and so on. And you can, of course, generate any kind of text output from that. So now the test should be green. All right. So let's have a look at the editor. So let's have a look at the Eclipse editor. Because I use the current version, I only have the Eclipse editor. I will later show you also the web stuff and the IntelliJ stuff using the latest hat we have. So what I did now is I spawned another Eclipse IDE from my development workspace where it ultimately installs the language. Okay? So I've created a project here already and I also have the file in place. And you see, everything I did was I wrote the grammar and then I wrote the code generator. And of course I wrote the test, but that is not executed, obviously, here. So from the grammar, all this is already derived. You see, we have syntax coloring. We have content assist, so it knows that at this point you can have either a device or a rule. I can have a door as well. Can be open, close, so things like that. And here, I reference these things. I said these are state references. So when I do content assist here, it proposes me all possible device states, right? And I can go and choose one or the other. And also I have navigation. That's all done by default. You don't do anything like the default scoping implementation is already kind of sensible for, that stuff has a name. And it sits in this that also has a name, so let's make a qualified name out of it. Right? That's the default. If it's not what you want, you change the semantics. You implement a different strategy there. You get rename refactoring here. So open, you can also like make it opened or so. You get validation, of course. So if I misspell something, I get an error. You have this outline tree generated by default, which works here as well. And then also the code generator is doing its work. So you see here, this is a generated Java code. And I remove the door again. And if I press save, then there should be, so some stuff removed. So again, I click save so you see it. So this is really also the idea. Usually, or in the past, if you use this kind of code generation technique in your project, it usually adds some kind of turnaround burden to your project because you have this extra step of code generating and so on. And that's really bad. So that really needs to pay off in order to pay that price. And so we made sure that this stuff really works well within developer lifecycle. It has fast feedback. Everything should be very fast. And it integrates into the tools we are using. All right. So that is the so to say, classical view on Xtext. Oh, I don't want to have that. Anyway. So, but what about more kind of Java-ish things like, so what we've seen a lot is domain-specific languages which are like cover structure, which are like more configuration and basically are a better replacement for XML, so to say. So you do structure a lot, and when it comes to implementing code, like having behavior, then you need to go to kind of painful code generation patterns. So, for instance, protected regions where you touch generated code, never do that. That's bad, because you accidentally delete your code. That happens. Or you need to have deep hierarchies where you have a manually written subclass where you override generated stuff. That makes the code more complicated than necessary. And if you look at all kinds of configuration files and so on, there's always sometimes this need to have some code in there. And usually in XML stuff we see EL, the expression language, or you can embed some JavaScript here and there, or Groovy or whatever. And it's all dynamically typed. And in Xtext, you don't need to re-implement an expression language if you need one, but you can reuse one that comes as a library, and I want to show that. So there's a couple of examples that are shipped here with the Eclipse plugin. And so we choose the Xtext domain model example here. That's a stupid domain model language which doesn't do anything in particular. It generates getters or setters and stuff that is not really useful. So you need to kind of don't use that in your project. It doesn't help you, right? But if you have kind of different technologies and you need to know, need to use a domain model in all these layers of different technologies, then you might want to have something like that and generate different views on that. So I just create these 3 projects, and as I said, they are already working, and I don't need to go into the detail here. I just want to show you what it looks like. So I can again launch. It's still open. Okay. Hot code replacement doesn't work that well, so I need to restart it. Okay. So what I can do now here is I can create a domain model file. I think the extension is dmodel, if I'm not mistaken. Yes, okay. So this is the domain model language, and I can, for instance, create a package, and then I can create an entity, and I call it person, and there I have a given name. And now you see that this here really is a Java type. So you see this language integrates with Java types, so you don't need to have kind of extra abstractions there that are not unnecessary. So if it's really a near code language there, then it's really cool because you have all the integration, like find references, go to declaration and so on, that all works seamlessly. And then the thing I wanted to point out here is that you can also have operations. And so I want to, for instance, have get full name that returns a string. And here I can have code. So I say if given name is null, then return name only, and else return given name plus white space name. Okay, so you have this structure, and you can have all kinds of metadata that drives your database stuff and so on, and you can also have logic there. And the point is, this is really easy to do. and it integrates also seamlessly. So if you have a Java class called main with a main method, we can create a person and set the given name and set the name, and then we say print on p.get full name. Sorry. This out. All right. And it does so, and if I navigate here, I end up in the DSL, so you don't end up in generated code if you don't want to. If you want to know that, you press right-click, and then there's some action, open generated file. Click on it, you end up in the generated file. And here you also see it generates a nice toString methods, the getters and the setters, and a constructor that takes a procedure, which is a functional type, so you can have a lambda expression in order to initialize the type. And also what's interesting is here, if you can also debug that stuff. So I'm in the Java code, now I choose step into, let's do it this way. And I end up in the DSL, and I can step over. What's going on here? And then go again. All right, so that's Xbase, kind of stuff you can reuse in order to integrate nicely with Java, if you have a code-centric domain-specific language. So if you have a business-oriented domain-specific language, then you probably want to have a browser. So this is some examples here. Xtext will come with support for 3 different JavaScript libraries. One is Orion, that's an Eclipse project. The other is Ace and CodeMirror. I'll use this one. There is an error. Why is that? Okay, that doesn't seem to work. Let's do this. Okay. So that's basically, as you can imagine, a web browser. It's just a widget, a rich text widget that you can put everywhere in web applications. And then there's the server side. So some of the services, it's mainly syntax coloring, runs on the client. And for more rich stuff where we need to know the AST and so on, that runs on the server side. But there's an efficient updating implementation, so it's also really fast. And it will support like the typical things like content assist, validation, and so on. And you can also do whatever you want, implement new services, and so on. Questions regarding that? Okay. And then the other technology here, that's IntelliJ IDEA. I've forgotten what the shortcut was to go into the presentation mode. All right. Does anybody know? Shouldn't it Command plus or so? No. All right. We go like this. So you see, it's basically it's again the same language, and you can do also find usages and the things on the given name. So you see there's already a main Java that uses a given name. So I can go there, see it here. I can also execute it. It's the same story as in Eclipse, basically. And the code generation stuff doesn't happen on save because there's There is save in IDEA, but by default everything saves automatically. So, but the code generation is still going on in the background. So you see here we have a person, and now if I type some numbers here, we have a person with some numbers. It's immediately updated as I type. And also then you can have it integrated in the build again. All right. Okay, so Xtext is a mature open source project that has been around for 6 or 7 years, and we have. I'm leading a team of 9 people, and we work kind of 50–60% on our daily, like on our time on it. The other 40% we help customers using it. So we also, and we of course work on the community and so on. And so we are in close contact to people who build products based on that. We have customers from like hardware domain and automotive and so on who build really big IDEs based on that. And then we also have kind of small DSLs for financial people and so on. So that's the ITMS website where we offer support and trainings. There is a conference that happens once a year on Xtext. It happens also in Kiel. So it's 2 days. We have 120 attendees every year. So the community comes together and exchanges ideas. And so what I showed you is the tip of the iceberg. There's a lot of stuff you can do with Xtext, obviously. So for instance, this extend language you saw, I mean, it's really, for me, I do all the development, if I'm allowed, with it. So it's as good and productively and tool-wise as Java, but it has just a much nicer syntax. And it's built with Xtext. And there's a book on Xtext and extend. And that's the website, and that's my last slide. Any questions now? Yes. Sorry, could you speak up?
What makes Xtext better than MPS?
The question was, what makes Xtext better than MPS? So for those who don't know, MPS is a meta-programming system from JetBrains. It's a projectional language workbench. Projectional means they don't work on text. It just looks like you are working on text. So you save XML all way long, and whenever you are not in the tool, you have XML. It's a different approach. So they use projectional editing that has some advantages here and there, and a lot of disadvantages, I think, because then you end up with this XML stuff, right? Look at the Git repository of some MPS projects, I know some, and try to figure out what's going on there. So it's really hard. But there is domains where that's nice, because with these projections, you not only have text, but you can also have special signs and so on. So and sometimes that's a useful tool. And ITMS also supports this tool. So we also have a strong relationship to JetBrains regarding MPS. We do support that as well. So if customers want to have MPS support, we do that as well. Any other question? Okay, then thank you. Have fun at the conference. And I should ask you, please put in the green, only the green things in the bucket. Thanks.